Hi, my name is Kurt Menke with Septima, and in this video, I'm going to describe the two new maps that are built into the Superior Bio-conservancy webpage and demonstrate how to use them. So here I am at superiorbioconservancy.org, and we've added a new tab here called Mapping. So I'll click on that, and from here you can explore the potential beaver population by watershed web map and the biodiversity connectivity in the North Woods. So these are two live maps which you can zoom in, zoom out, and investigate the data. I'm going to start with the biodiversity connectivity in the North Woods map. So here what we're seeing is what we call landscape permeability, where we have a view of what we call the structural connectivity across this region of the North Woods, or the Laurentian Forest Province. And structural connectivity simply means that it's not species specific, it's general connectivity for biodiversity across the study area. So areas in green are going to have higher connectivity, and areas in red, for example down by Green Bay, are going to have lower connectivity. And so we're calling this landscape permeability. I'm going to describe some of the functionality. We have a layers panel here, and with this we can left click to toggle layers off and on. So here I'm turning off the state boundaries. I can turn on other layers such as forests and protected lands, and then toggle them off. So you're going to be able to customize what the map shows as you use this. There's also zoom buttons up here, so I can zoom into the map. And as I do so, you'll see that that layers list gets a little longer. So now there's this layer called barriers. Barriers are large highway corridors that can be a barrier to movement for many species. So as we zoom in, you're going to see more and more layers become available. So this is the zoom in and zoom out buttons. We also have a zoom to start extent. So now that I've zoomed in a bit, I may want to go back to the initial extent of the map, and I can click this to zoom out to the full study area. The one below this is show the map in full screen mode. So I'll click this to make the map fill the whole computer monitor. Below that, we have a button to click to learn more about the data. So I can click on this and I can read about the connectivity data analysis, the data descriptions for what landscape permeability is, what the barriers represent, and other layers that we'll see as we zoom in and experiment with this. The formatting for this still needs to be worked on. When we embedded this into the Superior Bio-conservancy webpage, the formatting changed, so we will work on that, but that's what this button gives you access to. One other feature on this map is this tile that you'll see in the upper right-hand corner. This allows you to switch out the base map. So we're looking at an OpenStreetMap base map now. And if I click this, it'll switch to a satellite view of the area. And I can click this repeatedly to toggle back and forth between the OpenStreetMap and the satellite view. Another feature of this map is this find and zoom to a subwatershed search box. So if I want to zoom into a specific watershed, I can find it with this. So for example, if I'm interested in the Eau Claire, I can type EAU and it'll start auto-completing, and I can pick, for example, the Eau Claire flowage in Wisconsin subwatershed, click on that, and the map will zoom me in to that particular subwatershed. So here I'm getting a much more detailed view of the landscape permeability. One thing I recommend when you're zoomed in this tight, it can be nice to turn this layer off and turn on this layer called biodiversity linkages, which is basically the most connective parts of that landscape permeability. So these are basically linkages that we've extracted from the landscape permeability data, and we've classified them into critical, high quality, and medium quality. So you can use this when you're zoomed in to get a clearer, easier to digest view of the linkages and corridors in an area. And so here we can see that we have Wausau and we have an urban area, but you can see how these riparian corridors still form important linkages for biodiversity across barriers and through the urban environment. If I scroll up, another layer that becomes available when we're zoomed in this far is critical riparian linkages. So we can see there are bridges where these streams undercut the highways, and these are basically gaps in that barrier. And so our connectivity model identifies these as critical riparian linkages, which provide genetic flow through that barrier for many species. So I'm going to return to this box. I'm going to clear my selection, and this time I'm going to search for the Silver River. So when we start typing in names, it does autocomplete, and there are 3,000 subwatersheds in the database here. So we have combined, when there's a name repeated, the county and the state to make it a little easier to find which one you're looking for. I'm not looking for Silver Creek, I'm looking for Silver River, so I'm going to scroll down through the list, and I'm going to choose this one in Baraga County, Michigan. So the map will zoom to this Silver River watershed. And the last major feature of this site is that I can click on this watershed and I can get a box of summary statistics for this watershed, including the total acres of that watershed, the potential beaver population, 334, which is quite high, the river miles contained in that watershed, and then statistics on the linkages, areas of critical linkage, high quality linkage, medium quality linkage, and acres of core reserve. Now, core reserve is the last layer that we haven't really talked about yet. These are areas where there's just generally high connectivity. It's not a typical corridor like you may think. It's just a large region that generally has high connectivity, and we ended up calling these core reserves. We can turn this on and they come into this lighter shade of purple, and so we can see that a vast majority of this Silver River has high connectivity or areas of core reserve. And we've noticed a correlation. Oftentimes when you have a watershed with a high potential beaver population, it comes as no surprise that it often has very high important linkages within it. So now I'm going to go and choose the other Silver River in Houghton County, which is very close, a different Silver River subwatershed. And so again, we can click on this one and get the summary statistics, and we can see that this has an even higher potential beaver population. And we can also see that of the 33,000 total acres of the Silver River watershed, 25,000 of that are core reserve. So it's a very wild watershed. So I'm going to click F11 now to escape out of full screen view. And I'm going to explore the other map, the potential beaver population by watershed. So this map is set up very similarly to the other one. It has the same toggle for base map, the same search box for find and zoom to a subwatershed, and all the same tools for zooming, going to the start extent, putting the map in full screen mode, and lastly, clicking to learn more about the potential beaver population. So here you can read about how we calculated potential beaver population and what impaired streams are, which we're going to look at in a second here. So to remove that box, I'm just going to click the information button again. And I'm going to search for the same Silver River watersheds here. What we're looking at here are watersheds colored by their potential beaver population. So the darker green have a higher potential beaver population and the lighter green lower. And this map has several scales of watershed. So if we start zooming in using my center mouse button, it will switch to the next resolution of subwatersheds, and the legend will update to reflect those smaller, more detailed watersheds, again colored by the potential beaver population. And we can zoom in a little bit more and get to the final resolution of subwatersheds. And now I'm going to search for that Silver River in this map, just like I did in the connectivity map. And I'm going to go to Baraga County, just like I did in the connectivity map a few moments ago. And I can see that Silver River with a dark green, indicating that it has that high potential beaver population, which we found in the connectivity map. And when I click on watersheds in this map, we get kind of beaver-centric data for that watershed. We still get the total acres and the potential beaver population. Some of this is the same in both maps, But here we get things like the wetland acres, the percent wetlands, percent beaver suitable vegetation. And we tried to link these two maps together. So in the connectivity map, you get the potential beaver population. And in this beaver-centric map, you get the linkage acres contained in this watershed, so that we can tie these two maps together as you begin to explore these watersheds from both a beaver and connectivity perspective. So let's go to the other Silver River in Houghton County and see what that looks like from a beaver perspective. And we can again see that it has this nice high potential beaver population. But we see these red streams here. These are impaired streams. And if we click on the information button, we can see that these are streams which don't meet the state water quality standards because they exceed the maximum amount of one or more pollutants in a stream. And Section 303D of the Federal Clean Water Act requires states to provide a list of impaired streams to the EPA. So you can always use this information box to kind of understand what some of these data represent on the map. But we can see here that although this has a lot of connectivity and potential for many beaver, that it may be a higher priority for some action because they have it has a majority of the streams being impaired by one pollutant or another. So there is some action needed in this particular Silver River watershed. So again, I'm going to click F11 to escape out of this and close my information box here. So with this short introduction to these two maps, I encourage you to explore these data, explore parts of the study area that are of interest to you, and use both maps to learn more about the connectivity and the beaver population in particular watersheds of interest. Thanks so much.